let's see. So today, we can talk a little bit of a background about mapping. Has anybody used Leaflet to build a map at any scale? So we can talk about some of the mapping background stuff briefly, and then we'll talk about the stack. And we'll look at the application we built in a case study kind of way, and then some takeaways and a little bit of a Drupal 8. It's pretty bleak for Drupal 8 right now. So the basic idea with mapping, this is why I asked if anybody's used mapping before, is because it's what's referred to as data-driven journalism. We have a huge set of data, we filter it, we visualize it, and we tell a story. And really what you're trying to do is you're trying to answer a question, and you're trying to find a useful visualization. And usually we can let the data tell the story. And the idea is that we're presenting information in context. We can say things with a map that we can't say in words very easily. And the media industry talks about data-driven journalism a lot, and we're sort of stealing that and applying it to usability. And so this is a picture I like to show. This is somewhere in Denmark. They got this old fella in front of a map and this snappy-looking dude in a suit. That's actually Dasjo. He wrote the Geocluster module. Does a lot of work in the community with sort of testing, and I mean, he doesn't do Geocluster much anymore, but he's showing the old feller his way around a map, which is, you know, pretty interesting when you think about how this technology affects people at large. So the basic problem is this: you have a lot of points. You can't really use that. I mean, you could zoom in on that, but it doesn't really tell you much information, and you're sort of trying to create a density map in your head. It forces you to think much deeper than you need to. So the first idea, Google came up with this a while back, was client-side clustering, and it's sort of, you know, it's a lot more usable. You get a little bit of a context. You can zoom in, see what, you know, if you're looking at where things are, trends, things like that. You can get that pretty quickly out of this map. But this is where it breaks down, when you get into thousands of points. Because there are quite a few number of points that you can't even click on without zooming in. And you're not gaining any information from this except, wow, it's crowded. So, and technically speaking, if you wanted to client-side cluster that type of situation, you sort of get into a technical breakdown, because PHP is going to render each data point as a row of output. You know, and if we're talking thousands, that's thousands of rows. And generally speaking, with any map you're building, the pop-up content is loaded into the view, or I mean into the DOM itself, and the mapping library has to parse this, it clusters the points, and it renders the map and takes care of the behavior. And you're dealing with thousands, tens of thousands, hundreds of thousands of things all at once, and PHP gets slow, and JS gets really slow, and plus, if you're in mobile, you're asking that little device to do a lot of the heavy work. And we did some testing, and you know, something around between 5,000 to 10,000 points. After 300 points, I mean, client-side clustering is way too slow. So this is basically what's going on, and you can easily see the problems here. Everything is stored in GeoField, and in like something like entity map, you're mapping one entity, and it goes to Leaflet, crosses to the client side, and you have an interactive map. And we bring in Leaflet views to do lists. We still have an array of geodata. This list is still thousands of elements long, inherently slow. So this is a picture of what we created when it was launched. It's kind of pretty. We'll take a look at the real thing. Uh-oh. What did I do? Is it UST?
Yeah. Is there a hidden window asking you to confirm you're using this network for today?
I don't know, let's turn on the browser. Well, that's a drag. That's a real drag. Oh, there it goes. There it is. Okay.
You can just close that. Okay.
Would you just pull your browser window over to the right?
Yeah.
That's good.
All right. So, okay. So you can see, all right. First thing to note is there's probably, if you look and you did some counting real fast, you're going to see somewhere 2,000 to 5,000 points right now, and it loads pretty quick. And when you zoom in, let's grab a cluster. It does the reclustering on the fly. And one thing to note is that one of the performance gains here, performance tactics is bounding. So if you look, we're looking at the left half of the US, and if we grab it and pull it over, there's no points there. There's nothing mapped until I let go, and then it reclusters on the fly. As you go in deeper, you start to get the other marker types, and if you click on a pop-up, it does this soon. So these pop-ups are complex data. That is a organic group's name, a username, a profile to employer name, and the profile to has 2 different geofields on it. And the OG membership determines which layer it's on. And you can see here we have 2 layers. We have an alumni layer and an Activista layer. So some of these pop-ups, this one's a little bit more complex. There's 2 types of pop-ups, but this is something that's is rendered on demand with an AJAX call to a view. So we're not loading any of these pop-ups at page load time, which allows this type of activity to be really fast. And one of the things to note here is if you look right over the Twin Cities there, we have layers on top of each other. Right here, you can see there's a little 2 right there and a 160. Drives me nuts, but the client didn't mind, so we didn't fix it. You can see it kind of there if I deactivate the layers. But to give you an idea of the detail, I mean, this leaflet is really smooth. I really like it. And as you get deeper and you get to street view, you can see how, accurate they're mapped. You can start clicking around on these points. Works pretty good. And one of the key things to note here is these clusters, if you're familiar with map markup at all, this is just a single, it's not doing it. If you look at a cluster, there's nothing to it. It's just a marker icon, span with a number in it, and that's it. There's no data in that marker whatsoever. And if you look at, or the cluster, sorry, and if you look at an individual marker, well, these icons are broken thanks to the new team. They looked really nice. We used some font icons for that. That is just an icon, and the only information in there is a UID. And open it up. And there's actually there's not even any content in there. So what you're just spinning a flat markup with hardly any information in it and providing that extra layer of information on demand, which was a huge performance thing that we had to do to get the loading quick. Because when we tried to do it the traditional way, it would take minutes to load, and that was totally unacceptable.
Where was the catch for like the information for Ajax to know what you're clicking?
Oh, okay.
I didn't see an ID or.
Okay, let's take a look. So if you're on a cluster, there's 2 types of click behaviors here. There's, if you click on a cluster, it just zooms in 1 step, right?
Okay.
But if you click on a marker, you get the pop-up. So it knows what to do. Let's see, let's go to a different one. This one right here. There's a UID in there. Where did I put it? There's all the only information. We'll look at the JavaScript.
Okay, well, I mean, you can tell me there. I just didn't.
Right. So basically, the idea is the only information contained in that marker is a UID, and the view that is pulled with Ajax provides the information to put into the pop-up. And the nice thing about that is it's highly cacheable. We'll get into that too. Let's see. Yeah, feel free to stop me if you have questions. There's a ton of information in here. So let's see. I had the 2 boo items for the layer interference and the new maintenance team. So the basic recipe should look very familiar if you're familiar with maps. Address field for storing your locations, geocoder to do the geocoding, geofield to actually do the storage. The new element here is GeoCluster, which does the server-side clustering. Views, obviously, and then views JSON for doing the feeds, and then an adapter module for Leaflet. We did work on a 2x branch to provide panel support for the multiple layers. There's a demo that I have that you guys can download and use. It uses the 1x branch and uses beans. So if you want to use panels and or multiple layers, you're going to have to go with 2x, and then the Leaflet Integration module. But we need a metric load of patches. So I'm assuming that you want to build something like this. So what I did is I created a starter kit that you can spin up, and it is here, the README. This is what it looks like out of the box. We can take a look at it, but there's 10,000 points, and it's clustered super geometrically. The kit is built with Grunt Drupal Task. It's phase 2's sort of starter kit. It uses Composer, Node, and Grunt, and it's pretty straightforward to spin up. Just a couple of commands with Composer and npm and Grunt. If you haven't used Grunt Drupal Task, you should try it. It's Drush Make on steroids. The instructions are here. If you guys find mistakes and you use this, please submit an issue or a patch. I would love to I want to keep this updated until we have enough community documentation, because there's not much documentation out there. That was one of the problems that we had. So we use the kit. It has the complete make file to spin up the entire site. It has Drush commands to build the demo content and to give you just the basic framework to build your application on. But it does not include all the patches that we use for the client build that we're going to talk about. But it includes the minimal state that you need to pull together. The client build is in a separate Git repo. It's here. It's a standalone feature that you can use in Drupal 7, but it's got Profile 2 stuff. It's got patches for dealing with data coming in over relationships. It's got a couple extra views patches for GeoCluster to fit our needs. It's a little bit more complex. It is up to date. It will build. Whether or not it would work in your site is probably another question. I would start with a starter kit if you're going to build something like this. Let's see. So, back to our original diagram where we knew that we see a lot of rows of output. The new diagram adds these yellow boxes. No yellow boxes, yellow boxes. The yellow boxes is where the goods are. Because you still have your geofield storage, but you have GeoCluster here, and your array of geodata, instead of just pushing a list straight up into Leaflet, through GeoCluster, it takes this list at the query level and creates the cluster, so you just have single elements, maybe tens, even 100 of them at the most, with thousands of points. And that goes with the bounding strategy through the visualization engine in GeoCluster and comes into the map. So the idea is that we're doing this clustering at the query level. And the information that is required to do the clustering is created when the nodes are updated or saved. So the actual operation of clustering is very compute non-intensive because it's just querying a spatial index as opposed to doing geometric functions and measurements and all this stuff. So the keys here again, it's a query level cluster. And PHP and JavaScript only see this list of clusters or sparse points. And this is where the performance gains are achieved. Because if PHP doesn't see this massive list, JS won't see a massive list. So geohashing is sort of the key to this. The Wikipedia has a really good page on the geohash algorithm. I mean, with this sort of outside the scope of this talk, but in a nutshell, it creates a spatial index for geofields that can be queried just like a standard query. And what you're doing is you're saying, hey, I want to know about this quadrant of space. How many points are in this space? And you can know that by the geohash. So this is something I would read if you're into it. There's also a thesis about this, which is a pretty good read if you're into performance. Let's see. Yeah, and again, when you create an entity or update an entity that has latitude, longitude information, GeoCluster gets involved with entity pre-save, creates the geohash columns, and creates the data for querying later. And that's, again, the key performance gain there is it's the clustering, quote unquote, the work of doing that is done on entity save as opposed to entity view. So, back to the starter kit. We'll take a look real quick. Let's see. So, this is what you're going to get when you spin it up. Oh, it's slow today. You're going to get a full site. You're going to get some tabs up there, and you're going to get this map here. And you can zoom in, yada yada. You can take your, all of. It's kind of the same deal that we just saw. You can see it's 10,000 points here. It's still pretty quick. Right now, it's thinking. Sometimes it gets a little confused. It's hitting your local host hard. If you're running this locally like we are, this thing's hot right now. Probably hear the fan. But there's some other tabs up. Oh, see there, it's snapped together. And it just has a simple pop-up. But this one does not do the Ajax info bubble loading. That's something that we built. But this will give you the basic architecture to build on. And it's really quick to spin up, so you could work from this and modify your way forward. So you're going to need, I would start with the starter kit. You're going to need a feature module to hold your configuration. I would add in the dot module, do your custom code there. You're going to need some JavaScript to implement the behavior logic of your map. And you're going to need a debugger because it's fairly complex. And we need a fair amount of UI polish for our implementation. So one of the first things that we had to do, this is a migration. There was like 18,000 users coming in. And this is why we decided to look at server-side clustering, was because we were operating under the assumption that it was going to be an opt-out. Everyone was going to be mapped via one condition or another, and they were going to have to opt out. Well, on launch day, it turned out it was opt-in, and we only launched with like 5K points. But the key problem was they didn't have any geo data. They had some other crazy arcane mapping. All they had was addresses. So we did a one-shot import with migrate module. The next question was, how do we get around Google's 2,500 points a day? So we installed a cron job.
Sounds familiar.
We put a cron job in production. After a migration run, it would geocode 100 points an hour, so that we would get 2,400 a day. And after however long, new users were continuously migrated. It was continuous migration. And before launch day, we turned the cron job off, but we used this handy Drush geocode backfill command. This is pretty cool. Is if you get down here, there's an example right here at the top. Here you can limit the number of entities. You can say which entity type. And like we were doing field collections, we were doing user profiles. But this was really nice because we set that to 100 and had some logic to pick the entity for the day, and it would just code that up. And it was nice because then the people that were managing the content and making sure things were geocoded only had 100 to deal with a day, as opposed to thousands per day. So that worked out pretty well. So one of the other points of pain, we have a lot of locations where businesses, where there was multiple users. And Leaflet doesn't really discern between a lot of points really close together and a lot of points right on top of each other that are exactly the same spot. So we came up with this term called monolithic clusters. And what that means is, let's say you have 100 users at the same location. That's a monolithic cluster because all of their geodata is exactly the same. But we had to provide a different interaction based on whether it was monolithic or not. So we implemented some custom logic. Oh. How big is that? Let's make that bigger. Let's see. There it is. So this was a render fields alter. Can everybody see that? So I mean, it's really not rocket science. I mean, it's pretty simple, but we just used negative logic to figure out if it was a monolithic cluster. We just set the assumption that it is monolithic, and then run through, take the first geo point, set that as the reference. As soon as we find a mismatch on either latitude or longitude, it's not monolithic, it breaks out. So 9 times out of 10, this is going to break out after the second iteration. And we had maybe 2 instances of monolithic clusters that were bigger than 10. So this didn't really impact performance that well. But the hardest part here was figuring out where in the call stack to put it. And it ended up being in hook, views, GeoJSons, render fields, alter, which obviously comes from views, GeoJSON, but finding the proper point in the view stack where to put that was days. It took forever to figure that out. And that's what the problem with this module was figuring out where in the call stack to put stuff. And so here
What does that end up looking like, your monolithic clusters?
Oh, let's take a look. Can I find one? Is the key.
Because we had the same issue and used the spidering feature.
Right, so did you use both client side and to do that?
I believe all of ours is client side.
Oh, okay. Yeah, so that was one of the things I thought is the spidering was really cool. It was a really nice interaction.
Yeah, because we're getting close to the point where we have so many data points we're going to have to go to server side.
Now it would be interesting to like have them both so you could have that interaction. Let's see, what were we looking for again? Oh, what the monolithic clusters look like. Let's see. There are some in New York City. And because the icons are broken, it's going to be hard to tell, but there we go. May be able to find what the markers is. You see this purple marker?
Yeah.
Multiple vistas. That's the one that's a monolithic cluster. In essence, it's the same thing as a big cluster. It's just we redefine the interaction for it, and we can look at the JavaScript for it. Like here's one right here. It's just there's only 2 at that one.
Sure.
But it's a different view. It's a call to a different view, so it builds a different pop-up.
Okay.
There may be more that are more interesting. There's some other ones. No, there's 3 there. One there. But the idea is that there is a discernment between all these points on top of each other and all these points close to each other. Let's see. Okay. So yeah, let's take a look at the JavaScript. It's pretty interesting. Okay, so to build this with the Leaflet API. Wait, should I make that bigger? Yeah. You're overriding. There's a script in views GeoJSON that defines the behavior, and up at the top there, we're overriding it with the typical namespacing in Drupal. We did a bunch of stuff for the different icons. We used the awesome markers library and font icons, and that's what this stuff at the top is all about. And in PHP, we were counting that we were knowing if we're rendering a point, a cluster, or a monolithic cluster. So there's some logic here to figure out which icon to show. And we use sort of the standard stuff. There's some hard-coded stuff in here that I really hate. There was a super group in OG that had some special meaning, and the ID never changed, so it was group 18. But the first, to do the Ajax pop-ups, so this was all icon stuff. This is the click function here. First thing we're doing is looking to see if we're looking at a cluster. And if we are looking at a cluster and it's monolithic, we do this other function, click on clustered, which is just a simple zoom, nothing really exciting there. If that fails, we have loading spinners, which you saw when we click on it. This is the first time that view is rendered. It might take half a second, so we give a loading spinner. Once it's cached, it comes up automatically. But it's pretty, and we do, we place the spinner where the click was. And if it's monolithic, we're going to do this leaflet pop-up content. And there you can see the only information it has is the UID, and that's it. And we'll look at that function. Let's see. And there's some other layering stuff here, like alumni versus active. But this is your function of interest is that pop-up build. Because here you can see it's accessing the view of Ajax. It's the map pop-up single alum, and the argument is the UID, and it does the get JSON, pulls the information back, and it takes that information and goes into the build pop-up. I mean, that was pretty straightforward. We're just taking, so we get the information from the profile back from the view, and so we just go through and construct a DOM element, give it some style tags so that we can style it statically. Do all the building, append the pop-up container, and there's some other custom application logic for behavior here, and we just go back. But the key performance item here was the accessing of the view with Ajax right here, this piece right here. And this is nice because this is all uber cacheable, because that is static. It's always a number. So, I mean, if you get a lot of visits to a particular area of a map, this cache is going to warm up fast, and it's going to be quick, even on mobile. Let's see. So another interesting one that I can't demo because I can't log in anymore is focusing the map on the current user's location. Because the idea is that this Volunteers in Service to America, one of the things they wanted to do is encourage people involved to make local connections. So when they hit the map, it zooms them in on their currently mapped location, and obviously it shows them people near them. The way we did that was, that's back in the module file. Let's take a look. It's pretty straightforward, also not rocket science, but it was just a matter of figuring out where to put it in the call stack. And this one was hook LeafletGoJSons map pane alter. Again, this has only worked with 2x because it requires panels. It's pretty straightforward. We just grab the user, figure out what type of user they are, load them up, get their longitude and latitude.
Are you using their stored profile information?
Yes.
Okay.
So every user has 2 geofields. One where they work and their personal address. And if they no longer work, their personal address is mapped by zip code. So We yank the information out that we send to Geocoder to just give them a zip code pin, just to give people an idea where they are. But yeah, we're doing we're loading that stuff up straight out of the profile on the fly. It's still fast enough. I thought it was going to be slow, but field get items and all that. And we're loading up a field collection. I mean, you would think on paper, this is going to be slow. There's no way this is going to work. But it ended up working. And then we take that information and we just set the map-based information with this new center based off them. And the zoom was sort of, you know, well, I think was that a statically set? Yeah, we set the new zoom at 10. It was just sort of, we picked that. And they liked it. If I could log in, I would show you. It's pretty rad because the map just kind of goes in on them and it shows you where you are and who's close to you. So I already talked about this. The people who no longer were active but wanted their record map to show what part of the country they were in, we would send just their zip code to Geocoder. I mean, that was pretty simple. And it was just this function here. This hook form field UI field edit form alter. Wow. We took out, what did we take out? This is not the right function, is it? No, this is the widget function. Sorry, wrong function. Next one. There you go. So all of their information is stored, but we didn't want it mapped. So we took everything that was not street level out. I mean, some of this European stuff, sub-administrative area, dependent locality, we left in. So this covers like global addresses to this postal code level around the world. And it was just a matter of yanking it out with an unset before you send it to Geocode. And it came back with a pin in the center of the zip code. I mean, not all that interesting. So, multiple data layers. This is important because we kind of saw the concept of active versus alumni. And that was sort of how the client wanted to sort of parse the data into like sensible pieces. And it was driven by an OG membership. And so the view, we couldn't build a single view that could dynamically give us two layers that could switch between. So we had to make them in two separate data layers. And the 2x, did I link to this? Yeah, we ended up releasing this, the LeafletGoJSons 7x.2x. This gives you panels, multiple data layers, and a few performance tweaks. But if you don't need it, I wouldn't use it because it's, well, there's duplication because there's the bean implementation and there's the panels implementation. If you use 2x, you have both at your disposal. But there's a lot of duplicated code in there, and I think it would be nice to go object-oriented with it and give the core of it to be one thing and have the bean implementation and the panels implementation just extend to base class. But that was a little academic for another day. So the main issue here, deciding if you want to go server side, is how big we need to go. And like I said, we were looking at 18K at the get-go. So, you know, we're looking at a scale of 10 to the 4th. So the backend is pluggable. You can use PHP clustering, which is not much better than client-side clustering in JavaScript, because the query still produces a list of 10,000 or more, whatever your list size is. And MySQL is your first step towards performance gains because you're clustering at the query level, and the output of your query is already clustered. PHP sees tens of rows, JavaScript sees tens of rows. And there was talk of this Apache Solr clustering, which is supposed to scale upwards of 10 to the 6th. We didn't try it because we didn't need it. It wasn't actually working, but if you go to the GeoCluster page, it's mentioned. There's some resources there. We didn't have to go that big. It would have been interesting to test. But if you check out the thesis by Dasjo, he does a lot of performance benchmarking with cold caches. And his goal was similar to ours. He wanted 1 second page load or less. and he's looking at scalability here. And you can see this is client-side clustering is the blue, just Leaflet all by itself. And the PHP clustering, as you can see, not much better. It starts to break down just beyond a couple hundred. MySQL, you know, it's starting to break down right around 100K. Obviously, we didn't go that big, so we don't know, but we were well under a second at 18K, 20K. I mean, we're almost up to 24. I mean, it's the same order of complexity, but yeah, so this is pretty amazing if you take a look. I mean, it's still under 200 milliseconds, you know, upwards of 1 million. So I'd like to see that. I don't know if it works, but if you need something that big, it's worth a try. So the possible improvements. So like we were talking, server side is great when you're zoomed out and you have thousands of points, but when you get zoomed in, you know, you're going to be down to maybe 100. So one of the thoughts was to sort of provide someone do a threshold where you didn't use the GeoCluster client-side query level clustering when there was a smaller data set. How that would be implemented, I don't know. But the interaction, the spidering interaction is much more, I don't know, it's more eye candy-ish than what GeoCluster provides. There's an issue for this on D.0. There hasn't been much movement on it in a while. What's that?
Chris is my development partner on that.
And then here's Dasjo. This is the guy that wrote the thesis, right? He's Austrian. Not much movement here. And since 8 months ago, I think it's a great idea. If I build another map, I think I may take a look at this if I have to go large scale. So we saw the layer interference because we have clusters that end up on top of each other just kind of by chance, because you don't really know where they're going to end up because it's sort of based on your view and your bounds. That's kind of where your clusters are going to go. You can alter you can tune sort of how close they go and how many clusters go in the group, in the view. But really, it depends on your viewport size. You know, so many different, you know, how big the map is. All this, it depends on so many things. So one of the ideas I had was let's come up with a way to, once we have our layers that are clustered, collapse them into a single layer and cluster them again. So I'm not sure exactly how that would be implemented, but it makes sense conceptually. And the other thing that we have here is when you're looking at a map, you're looking at a URL, but the data that goes on the map, you're looking at a different URL, and that's this one. And it has the bounding parameters in it and the zoom level. That zoom level is a floating point integer. So depending on what size you are, what device you're on, that's going to vary, and it's going to take a long time for the caches to warm up on that. I mean, it's a good thing it can query very, very quickly. So one of the thoughts we had was, hey, let's quantize that so that they're integers, or maybe they're, you know, just go out to 1 decimal point so that we have a finite number of zooms so we can get the caches to warm up relatively quickly. There is an issue for that as well. That is not much movement. Yeah, last updated February 2015. So, yeah, not much movement there. But it would be a good enhancement. So really, it's not perfect, but it does work. It sort of met the requirements of the client, and we learned a hell of a lot about the Views API and server-side clustering. I mean, it's in production, it works, it hasn't broken yet. It's fairly complex, and I don't know if that's because of the way GeoCluster is written, or there's so many moving parts. It's really easy to break. So, Drupal 8. This was disappointing. Address field, we don't have a release. So, it's in development. It's very common. I would expect something to happen there. Geocoder has a dev release, and Geofield is already in alpha. GeoCluster, there is nothing going, nothing moving at all. We have views in core.
and views GeoJSON. We have a sandbox. I haven't tested it. Leaflet-GeoJSon, nothing planned, and the Leaflet library has a dev release. Some of this stuff, if you choose to not implement your map feeds as GeoJSON feeds, you might be able to get around those two. You could probably get around these two, but I mean, GeoJSON feeds are pretty fast and widely accepted, so I'm not sure. I mean, I can't see how it would be that difficult to port it over, but really, the biggest problem that we have is storing of the Geohash data in your geofields. So in Drupal 7, we had to apply a patch to core to allow hook field schema alter to be implemented. And then Geocluster implements this field and spins through the database, and any geofield, field data, field, geofield, blah, 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 it adds the Geohash columns. So the question is, I'm not sure in Drupal 8 how, if the field API is exactly the same, if they're implemented exactly the same, if you would even need this type of hook. But there was an original. I mean, do you guys know enough about Drupal 8 to say anything on this? No. So yeah, I'm not sure, but this is the key. We need to be able to store the geohashed information on the geofield tables themselves. And how do we do that in Drupal 8 is, I don't know. The issue queue that went along with this patch makes no mention of Drupal 8. So I'm not sure. So just some resources. Geocluster demo on GitHub. The production map. The Drupal feature that implements the production map. The Geohash algorithm, and the thesis if you're into benchmarking and learning about performance and taking a closer look at the Solar implementation. I'm MP Geek. I'm around. That's all I have. Do you guys have any questions?
It's a lot to take in.
Yeah, there's a ton of information. So what I was going to do is I was going to post, there's a couple blog posts on the Phase 2 blog that I wrote about this. I'm going to post these slides. I'm going to repost the demo links and the other GitHub links. I'll tweet them and I'll put them up on the TC Drupal site, the post for this session.
So we have a large data set map, and early on decided we're not going to use views, just for performance, and build the GeoJSON array through custom module and send that. I was curious what kind of tweaks you needed to do, if any, with views GeoJSON to sort of
Well, let's see. We
get
had
things moving a little faster.
Well, there was the thing about views GeoJSON was it made several assumptions about how your data was structured. First, it assumed that the geo data would be in the base table of the view. Not so. Came in over a relationship. Then it assumed that locations were only mapped from nodes, not general entities. So there was a lot of we had to patch up some stuff. But what I did like about the GeoJSON format was that it was fast, because it's just text, and it's widely accepted. But the whole key with using views is slow, we know this. But we sort of circumvented that by using GeoCluster because it did the query level clustering. I mean, those queries are complex, and they are not fast. I mean, the GeoCluster module could probably use a views expert and really dial it in. But did you use anything like any field queries or anything, or how did you?
I believe he built it using any field query.
Did you get a chance to compare it to a views implementation?
I don't remember. It's been a few iterations.
I mean, I'm a fan of using views when you can, just because.
Yeah, as am I, and so I tried to push that. I'm mostly the project manager and front end developer on the project, so I'm always trying to push. Let's use the well-tread paths, right?
Yeah. Well, that was the problem we ran into. Is there was nothing out there.
Right.
We were almost thinking, going third party with it. With what is it? I can't remember the name of the service. CardoDB or something like that. But they wanted to do this and give it back to the community. But Geocluster was the key. That we wouldn't have been able to do it without Geocluster. But it needs work as far as performance is concerned. Because our data set's only like 5K right now. How big is your data set?
I don't even know right now because it's a whole bunch of different stuff.
Yeah. See, this doesn't do polylines or anything. This only does dense points.
Yeah, see, we were beginning to import data and build records, 10,000
Wow.
more, and it runs regularly, so.
Well, the thing that I did find is that because there's nothing out there, anything you build is going to be highly custom, and it's a matter of figuring out what of that can be generalized and given back.
Yeah.
So a lot of the sort of business logic ended up being in that 2x branch of Leaflet-GeoJSons, and it's all configurable. So we had enough budget to do that, but there's just not enough stuff out there because people don't think it can be done in Drupal. In my opinion, why it's not pursued. But we have a solution. I'm sure there's other solutions out there, but. Thanks.
Thank you.